let's go back to middle school for just a moment. When you first learned to graph on a coordinate plane, you had an x-axis and a y-axis, and your teacher handed you a coordinate and said, here, graph this. And you were like, I got this. I'm going to go 5 to the right. I'm going to go 2 down. I'm going to put a dot. I'm done. Like, yeah, that wasn't so bad. These were rectangular coordinates. I mean, look, it kind of makes a rectangle if you think about it just right and look at it just right. That's a poorly drawn rectangle, but whatever. So these are rectangular coordinates. Not all coordinates are rectangular. I flung that away like I'm mad at my rectangular coordinates. Be gone, rectangular coordinates. Some coordinates are a radius and then an angle. These are polar coordinates. And when you think of polar, you probably think of like North Pole, South Pole, and it sort of makes sense. If you were looking at the very top of the Earth and the longitudinal and latitudinal lines were drawn on the Earth, well, that would be a huge endeavor, but this is what it would look like. Like if you're looking down at the top of a globe, this is pretty much what you see. It's polar. Okay, just saying. We're gonna call this one A, call this one B, call this one C, D, and E. And when I plot them, I'm gonna label them just so you'll see where they are. And there are some smudges on mine, and I will remove them now. Okay, they're not removed, but they're covered. The radius is 2, and the angle is pi over 3. So start by going out 2. Use a green pen. We're going to go out 2, 1, 2, and we're going to go around pi over 3. Excuse me. Pi over 3, of course, is here, so we go out 2 and around pi over 3, and that's it. Now, it said plot each of the points on the polar plane and name each coordinate in at least 2 other ways. We're not going to do that for all of them, but we could fix it, not fix this, but we can get to this same location in more than one way. However, back to middle school, there was only one way to get here. Move forward 5, move down 2, you're done. How can you get here? You can move forward 2 and around, circular motion, pi over 3. You could move forward 2 and around a whole circle plus pi over 3. Let's put that. So this is an alternate way of doing it. I could go 2 and then 2 pi plus pi over 3, and 2 pi plus pi over 3, 2 pi plus pi over 3 would give me 6 over 3 pi plus pi over 3, and this can happen in your head, and you'd have 7 pi over 3. Just throwing that at you, or flinging it off my paper. 7 pi over 3 is going to put me in the exact same place. Let's do it one more time. I could get here a different way, and I'm just going to go ahead and go crazy on you. Perhaps my radius is negative. Now, I know you're like, negative radius, you can't have a negative distance. I hear you, you're right, but I can move in a negative direction. So let's start by doing that. Let's go -2. Let's pretend like we started by going here, and then I want to get here. Now, I have a couple options. I could go back around. This could be blurry, and it could get in focus. There we go. I could go back and then around this way, or I could go around this way. Now, this way would be a positive angle. This way technically is a negative angle. Let's do the negative, just to spice it up. I could go -2, and then I would move 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Now, I know you're saying, no. I'm not moving 4 pi over 6. 4 pi over 6 is somewhere else, 2/3 pi. 4 pi over 6 is here. I know, but that's the amount of the angle I moved. That's how open the angle is. So -2, and then actually -1/6, -2/6, -3/6, -4/6. 4 over 6 is 2/3. That's another way of naming it. Are we going to do that with all the points? No. Are we going to let it be blurry like this? No. It stops now. Now. It stops being blurry now. There. First try. All right. 7 over 2. So that would be 3.5. We'll do this one in red. So 1, 2, 3.5. And then we're going to go around to 5 pi over 6. So, and it's there. And this one would be B. Okay. Let's do this one other way. Let's not follow the directions on all of these, because at some point you're going to be like, yeah, I got this. So let's actually start by going 3.5, and then we could go backwards. And there's several ways of doing it. If you weren't thinking that way, you're like, why don't we do this and then go here? That's fine. Why don't we do this and then go here? That's fine too. I'm going to go this way, and then around with a negative angle. So let's also call this one 7/2, comma, and then pi/2, technically negative pi/2, 2pi/2. All right, that's getting complicated. So negative half a pi, negative 2/2 of a pi, and then a little bit more. So what we just did was we moved the equivalent of, and just kind of watch where I'm going here, the same distance as if we went zoom, which would be 7pi/6. We just went 7pi/6 in the opposite direction, so it is negative 7pi/6. So that's the same thing. Okay, switch colors again, going to purple this time, and C is at -3, and then pi/2. So I'm going to move in the positive angular direction, which is counterclockwise, pi/2. So -3, and then positive pi/2. I don't end up at pi/2. I end up at this, which is 3pi/2, and the lights just went out in here because I've been sitting still for so long. So this one is C. And hopefully you notice that obviously this lands on an axis. So it would not be very difficult for me at all to stand up and get the lights to come back on. There we go. Motion detector. Motion sensitive lights. It wouldn't be hard at all for me to go ahead and tell you what this would be if it was a rectangular coordinate. So whoa, what are you talking about? Rectangular coordinate. That's the middle school stuff. So if I was like, okay, this is C, what is it if you just were using your old middle school, you'd be like 0, -3. Now, the coordinate for A is a little bit different. That's going to be a little more complicated, and that's going to happen in the next video. That kind of thing is going to happen later. All right. Let's name C one more way, and then we'll move on from this one. I could go 3, and then I could go 3pi/2. That works. So go forward and then go with a positive angle. So 3 and then 3pi/2. All right, let's move through the last two very quickly, and let's not name them in other ways. 3, and then -5/3, so we're going to move around this way, and we're going to move around 5/3 in the wrong way. Well, the negative direction, angularly. So 1/3, hold on, I lost my place. 1/3, 2/3, 3/3, 4/3, 5/3. So that is D. And the last one is 1, 5pi/2. So 1, so we're going to stay here, and we're going to move around 5pi/2. Well, 5pi/2 is 2.5 pi. Usually we don't use decimals with pi, but we'll go with it this time. So 2 pi would take me all the way back around to where I started, and then another 1/2 of a pi would take me right here. And so this dot right there is